Defining and using the slope and y-intercept of a line. In this video, we're going to discover the meaning of the y-intercept and slope of a line in the context of some real-life situations. We're going to be able to see the relationship between these values and the equation of the line, and we'll be able to graph the line from the equation in slope-intercept form using those numbers. We're going to talk about graphing linear equations, but I want to point out some important features about lines in context so that you can see how they work. So we're going to pretend that these two graphs are the graphs of some stock prices. The price of the stock is on the y-axis in each case, and the number of days is on the x-axis. Now there's a starting point on the graph where the line goes through the y-axis, and that represents 0 days. For this first blue graph, that starting point is 20, and that means when we started keeping track of the price of the stock, it cost $20. On the red graph, the starting point way up here corresponds to $120. When we started keeping track at 0 days, the stock cost $120. The other thing we can notice from the line, the blue stock is increasing. The price keeps going up as time goes forward. But the red stock is decreasing because the price keeps going down as time goes forward. And we can say more than just increasing and decreasing, because if we mark some other points on these lines, we see that over the course of 1 to 3 days, the stock has gone up $10 to $30, and then after 3 more days, it's gone up another $10 to $40, and so on. So it's increasing at a constant rate of $10 every 3 days. The red stock, on the other hand, is decreasing. If I mark some points here, it's fallen to 70 in the first 3 days, and that's a drop of $50. So minus 50, it's decreased over 3 days, and that keeps happening again. This one's at 20. Over the next 3 days, it's gone down 50 again to 20. So it's decreasing at a constant rate of $50 every 3 days. The starting point of the stock price and the rate that it's increasing or decreasing are super important parts of the equation and the graph of a line. Suppose I want to graph the temperature on a certain day. At 6 a.m., which is going to be my starting point, the temperature was 50 degrees, so I could mark it right here on the y-axis. And at 11 a.m., which is over here 5 hours later, it was up to 75 degrees, halfway between 70 and 80, so there's another point. If the temperature were climbing in a linear fashion, I would be able to draw a straight line between those 2 points. And let's just focus on that starting point, which is at 050. And then how fast is the temperature increasing or decreasing? Well, it's increasing because as time goes forward, the temperature is going up. And it's increasing at a rate, well, in 5 hours, 1, 2, 3, 4, 5, it's gone up 10, 20, 25 degrees. So 25 degrees in 5 hours is the same as a rate of 5 degrees per hour. Now to write an equation for this line, these two things are all I need, the starting point and the rate. So let's see how that would work. Y equals, well, every hour that goes by for x, the temperature is going to go up 5 degrees. So if I multiply x by 5, then after 1 hour, it's gone 5 degrees up, 2 hours, 10 degrees up, 3 hours, 15 degrees up, and so forth, so that's good. But it didn't start at 0, it started at 50. So those up points are going from the 50 where it started. Isn't that neat? The rate is the multiplier for the x, that's the slope. And the constant here, the 50, is the starting point. It's called the y-intercept. So the equation and the graph are very closely related. The numbers from the equation appear in the graph, and the numbers from the graph are right there in the equation. Suppose I want to look at an equation that's solved for y. Y equals -3/2 times x plus 4, and use it to graph the equation. Now, in order to read the slope and the y-intercept from the equation, it has to be in this form, where it's solved for y, there's a multiplier times x, and a constant. And I do have that form. My multiplier is -3/2, and my constant is 4. Since I know that constant is where the graph goes through the y-axis, it's the y-intercept, or the starting point as we're moving in a positive direction, I'm going to mark it 0, 4 on the y-axis. Now this coefficient, -3/2, is telling us the rate of change, or the slope. So if I mark that down 3 and over 2, I get another point. And now I can draw the line by connecting the 2 points and then extending it in both directions. There's a very strong connection between the equation in this form, called slope-intercept form, and the graph of the line.